In this theoretical calculation, we are going to calculate the weight of 0.8 deciliter of water. So we know that the density of water is 1,000 kilogram per cube meter. This means 1,000 kilogram per 1,000 cube decimeter, as 1 cube meter equal 1,000 cube decimeter. So we can explain by this, as we know that 1 cube decimeter of water is equal to 1 kilogram of water. So 0.08 cube decimeter of water equal 0.08 kilogram as the mass of water. So we know that now the mass of water. We are going to calculate the weight of the 0.8 deciliter of water. The weight of 0.8 deciliter of water, we know also that the weight of any kind of substance equal the mass of the concerning substance times g as gravitation. Okay, so from that, the weight of displaced water is 0.08 kilogram as the mass of the displaced water times 9.81. The result is 0.7 Newton. So but I think you remember that we measure the weight of our solid outside the water, we get 4.8 Newton, and when we introduce the solids with the force meter, the pointer points at 4.2 Newton. The difference between 4.8 and 4.2 is 0.6 Newton. So this result should be 0.6 Newton. But as you can see, the accuracy of the measurements has its impact on the result. We've seen only with our eyes the level of water here, and we suppose it's exactly 0.8 like the displaced water. So when we see the level of water here, we suppose it's exactly on the graduation of 8 deciliter. And when we introduce our solid inside water, if you see here exactly, if you see the zoom, make a zoom here, you can see that the level of water is exactly between these two graduation. Okay, if I move the cursor, you see it correctly that the level is between the two graduation, but we suppose that the level was on this graduation. All these little mistake or little consideration make impact on the calculation. So the challenge I give you as physics teachers in Africa is to make your equipment, to create your apparatus with your student as better as you will have the exact results of the theoretical lesson that must be the same of the results of the experimentation. Okay, it's over to you to make a better equipment. So generally, the Archimedes principles formulas is this one: the weight of a substance outside a liquid. I will say a liquid generally. It can be water or gases. So the weight of a substance solid outside of the liquid or the fluid is equal to the weight of the same solids inside the fluid plus the weight of the displaced fluid. Okay, so here, as we are using water, I can see that the weight of our solid outside water is the weight of the solid inside the water plus the weight of water displaced. Okay, so this weight, as the weight of water displaced, is called the upthrust force. So this is a kind of experimentation you can manage and create with your student wherever in Africa, for the student can really understand the content, the subject. Okay, thank you.